Well, hey there kiddos, and welcome to your video on correlation coefficient. It's going to be very similar to the stuff that we talked about in class today, so you should feel like some of this is a repeat, and then there's a couple of added things. So we're going to start with talking about the correlation of a data set. So I can have two variables, an x and a y variable. Don't really know what they stand for, but they can correlate or have a relationship one of three ways. They can be positive, they can be negative, or they can have no correlation. A positive correlation looks very similar to like the graph that we did today with our guesses on the age thing. And so what that happens when you have a positive correlation is the data increases as you go from left to right. And so that's what a positive correlation looks like. A negative correlation is just the opposite. It, instead of increasing as you go left to right, it decreases. And so it looks something similar to this. No correlation is when the two pieces of data have nothing to do with each other and you just have this freckled little graph with dots all over the place. So those are your three types of relationships, and we're going to talk about how some data relate to each other as we go through this. So here are some examples. This first example right here has a positive correlation because as you go from left to right, the values increase. It does start to increase. I would not say that this is linear. It's sort of all over the place, but you can call it linear if you want. I could draw a line of best fit through there. It just wouldn't match it very well. And so if I'm going to describe my relationship between x and y here, I'm going to say that as the x values increase, the y values also increase because that's what makes it a positive relationship. Both variables increase. So I'm going to say as x increases, y increases. So both variables are increasing at the same time. That's what gives it a positive relationship. This next example has a negative correlation. You can see that it decreases as it goes from left to right. It's definitely linear. That pretty much, I mean, you've got several dots there that line up real good. And so if I wanted to describe the relationship between these values, as x gets bigger, as I increase the x values, the y values get smaller. That's what makes it decrease. And so for this one, as x increases, y decreases. And so that's what's happening with your variables there. One will increase, the other will decrease. That's what gives it that negative shape. This one here has no correlation. The variables have no relationship to each other at all. They're just sort of scattered all over the place. I would definitely say it's nonlinear. There's dots everywhere. And so the relationship between x and y, there is none. Sometimes as I increased x, the y increased, and sometimes if x increased, y also decreased. There's not a relationship between the x and the y values. That's why there is no correlation there. So now we're going to determine if some relationships have a positive, negative, or no correlation. So what you need to think about is as one variable increases, does the other variable increase? If it does, then it's positive. Or does the other variable decrease, which would make it negative? Or do they have nothing to do with each other at all? Sometimes two things can have nothing to do with each other, but you can still have a correlation. So the first one says hours of studying and grades. Well, if the hours that I study increases and continues to go up, then your grades should also increase. That's how that should work. This should be a positive correlation. Now keep in mind there is an argument against all of these, but as a general rule, that's how it works. The next one, test scores and shoe size. Well, I don't think they have anything to do with each other because the size of your foot has nothing to do with what kind of scores you're going to make. So this has none. The number of pets a person has and the number of books the person reads. I don't think those two things have anything to do with each other either. You can have a whole lot of pets and still read a whole lot of books, or you can read a lot of books and don't have any pets at all. So I don't think these are related either. How tall a person is and how fast they drive. Those two don't have anything to do with each other either, because as your height increases, it doesn't mean that you drive faster. It also doesn't mean that you drive slower. It just, how fast you drive is how fast you drive. So number of days absent from school and grades. Well, so as my absences increase, as I have more and more absences, my grades probably decrease because I haven't been there to learn anything. So this one is definitely negative. And then temperature and the number of people wearing jackets. There's a couple of ways to look at this. You can say that as the temperature gets warmer, fewer people wear jackets. So one goes up and the other goes down. Or as the temperature gets colder, more people wear jackets. Either way, they're doing opposite things. Never ever is the temperature and the number of people wearing jackets moving in the same direction. As it gets colder, you don't have fewer people wearing jackets. That would just be weird. So this one has a negative relationship, because as one increases, the other decreases. And that's what we're trying to look at. So let's do a few examples. You're probably going to need your calculator. We're going to do some more linear regression, but now we're going to talk about this thing called the correlation coefficient. Correlation coefficient is just the number that determines whether or not the correlation is positive or negative. So it will tell you whether it increases or decreases, and it will tell you how closely the equation matches the data. So the closer the number is to 1, the better a correlation it is. So here's a pretty little number line for you. If you're at 0, it doesn't correlate at all. That's not a very good correlation. Anything on the positive side means you have a positive correlation, and if you go all the way up and you get 1 exactly, then you have a very, very strong correlation. If you have anything in between there, it's just not as strong, but it's still okay. And then it works the same way in the negative direction. So here's how you find your correlation coefficient. There are directions in your notes, but there is an easier way to do it than what it says in the notes. So if you'll grab your calculator, and if you'll go to the button that says mode, you get all of this stuff. And mine may have more stuff than yours, but you still should be able to scroll down and you should see this thing that says stat diagnostics. And if you'll scroll down and find that stat diagnostics part, when you get down to it, you want to arrow over and turn it on. So you want to go to Stat Diagnostics, arrow over and hit enter on the word on, and now your diagnostics will be on. And so now when we do a linear regression, we'll be able to see our correlation coefficient, so we'll be able to know how strong of a correlation it is. So to get out of this screen, now that you've turned it on, you're going to press second and mode to quit. And so we're going to do an example. So this first question, number 5, it's 5 and 6 ask us to write the equation for each set of data, and then we have to determine the correlation coefficient. So here's our first one. I've got to put these numbers into my list like I did today in class. So we're going to go to Stat and Edit. If there's information in your list, all you have to do is arrow until the L1 or L2 or whatever list you're in is highlighted, and if you'll hit clear and then enter, it will clear out the list. And it looks like our numbers for X are 5, 10, and 15. And then I have to do my other column. So I have to do clear and then enter. And then it looks like my Y values are -7, -10, and -13. So I'm going to calculate my linear regression. So I'm going to go back to Stat. I'm going to go over to Calc. And I'm going to choose option number 4 for my linear regression. And so I'll hit enter to calculate. And I'm going to have new numbers. When you did this today in class, you just had your A and your B. And so we wrote down our A and our B, and we were done with it. Now I have these other two numbers, R squared and R. They are both correlation coefficients, but the one that we want to worry about is the R, because this is a linear regression. My linear equation doesn't have any exponents involved with it. Nothing is squared. It's just mx plus b. Then we're going to use the R, not the R squared. So we want to look at the value for R, and it says it's -1. The negative tells me it has a negative correlation, so it means it's decreasing. And the fact that it's 1 tells me it's a very strong correlation. And that means that this equation perfectly matches my data. So my equation here is y is equal to -0.6x minus 4. So this equation perfectly matches that data. That means that these points, if I plotted them on a graph, make a perfectly straight line. So number 6 here is the same, but I'm giving my information in a list. If you want to, you can make a table first so that you can see your x's and your y's. So I have -3, 4, 0, 10, and 3, 16. It's a little easier to see. And then we're going to go back to our calculator. We're going to go to Stat. We're going to go to Edit. My list is the same length as the list that's already in there, so I'm just going to type over the numbers instead of clearing it. So my first three numbers are -3, 0, and 3. -3, 0, and 3. And see, it just types over them and changes them, so you don't have to clear the list this time. If it were a really, really long list with extra numbers, I would, but since they're the same length, it's okay. And then I have 4, 10, and 16. Oh, we forgot to write something down. The correlation coefficient for this one, number 5, was -1, which means it's a very strong correlation. As a matter of fact, it's perfect. So now we're going to find the equation for this one. So we're going to go back to Stat, over to Calc, and we want option number 4 for a linear regression. So hit Enter to get Calculate. And I have 2x plus 10 is going to be my equation, and this time my correlation coefficient is +1. So this has a positive correlation. It's going to increase, and the 1 tells me it's very strong, so it's going to be, as a matter of fact, it's perfect. So I have y is equal to 2x squared plus 10, or 2x plus 10, and my correlation coefficient this time is +1, and so it is also a very strong correlation. So let's do one more together here, and then we'll talk about how this is going to work tomorrow and what we'll do. So now you have this one, number 7. You have the table of the average maximum daily temperature in January for northern latitudes, so latitudes above the equator. So first things first, we want to write the equation of the trend line. So I've got to go to my calculator, I've got to go to Stat and Edit, and I need to enter these values. So in list 1, I'm going to put all my latitude values. So I have 35, 33, and 30. 35, 33, 30. And then I have 25, 43. And then 40 and 39. And then in the other list, over here, list 2, I'm going to have to put my other values, which are my values for temperature. So I have 46, 52, 67, and then I have, oops, oh, we have a problem. I don't know how to type. 46, 52, 67, 76, and 32, and then 37, 44. And so we're going to do find our line. So we're going to go Stat, Calc, number 4. And my equation has these decimals like before. So I'm going to round to 3 decimal places. So this becomes -2.487. So I have y equals -2.487x plus 137.623. That 7 is going to round that to a 3. So I have plus 137.623. There's my equation for the trend line. Now the correlation coefficient, I've got to talk about it, and it wants to describe the measure of the association. So is it very strong? Is it not very strong? So we're going to talk about that. So if we look at our correlation coefficient, it's the R, and it's a -0.978. Well, that's pretty close to 1. If I rounded that up, it would round up to 1. And so it's going to be pretty close to 1. So my correlation coefficient, R, is -0.987. Sorry, 978. I did that backwards. And because it's negative, it means that I have a negative correlation and it's strong. So this line, if I were to graph it, would pretty much match the points on this. Now, C says the average maximum daily temperature in January for a particular day is 20 degrees. We want the latitude of the city. Well, this is your Y value because that's where I put it. This was X and this was Y. So I'm going to have to say 20 is equal to -2.487x plus 137.623. And I'm going to have to solve this equation. So I'm going to subtract 137.623 from both sides. So I'll grab my calculator and I'll have to do 20 minus 137.623, and I get that negative 117 number, and then to finish solving this I'd have to divide by the negative 2.487. So now I'm going to divide by negative 2.487, and this is what I get. I get the 47.29. We're going to round it to the nearest whole number, so the latitude of the city is about 47 degrees. That's about what it comes out to. So that's how you do this. You go turn your diagnostics on so you can get your r and your r squared. You're always looking for the r value because we're doing a linear function, and we don't have anything that's squared. And then so you just look at it. If it's positive, you have a positive correlation. Negative means a negative correlation, and then the value of it lets you know how strong it is. So that's correlation coefficient. We'll practice this when you guys come to class. I will see you then.